joining today. Today I'll be presenting to you the scenario Greenhouse Recycling Corporation. Greenhouse Recycling Corporation is a provider of recycling and waste disposal services to the industrial and medical customers. They have about 150 offices and 300 disposal facilities in the US and Canada. Their mission is to preserve public health and safety by providing the best available recycling and disposal services. In terms of the pain points, at the moment, GRC has grown by acquisitions and has remained largely paper-based organization, where there are severe gaps in the systems in terms of the automations and the integrations. And therefore, as a project objective, GRC has decided to use Salesforce and in order to achieve more integrated system capabilities with their backend systems and provide new digital services to their customers. Quickly moving on. Next, in terms of the system landscape, I would start from the middle. So in Salesforce, we would be using a customer community to allow the customers to be able to access the portal services portal capabilities within Salesforce. Also, we would be using omnichannel so that based on the skills and the availability of the agents, the customers could reach out to the specific agents to help resolve their issues. We would also be using a CTI system. So it doesn't clearly say which CTI system. So I'm making an assumption here that we are using Amazon Connect, and therefore we can use the Service Cloud Voice here under the hood, so that and under the hood Amazon Connect, so that it can provide the CTI and the integrated voice response capability, so that and also the routing capabilities within the CTI. Also, we will be using mobile publisher, because then there is a branding mobile app like experience provided to the customers to be able to access the community. Also, we'd be using Heroku as our off-platform storage capability, so that the data is kept on platform only as long as it's needed, and the data is offloaded to Heroku. For this, we would be using the Heroku Connect capability, so that the Heroku Connect can keep synchronizing in a bi-directional way, and there will be a Heroku scheduler component which can on a specified schedule basis copy the data and move it into a non-connect schema and into the archive tables, and after that, on completion of that, delete the data from the connect schema based data tables in Heroku, and therefore which on a sync basis would get deleted from Salesforce, and hence the archival operation would happen. Also, we'd be using Tableau CRM for some of our business intelligence, trending reporting, historical trending reporting capabilities. Moving to the right side, in terms of the identity, it says that the customer has already implemented single sign-on, but and which is connected to their enterprise-wide Active Directory, but it doesn't clearly say which single sign-on provider. So therefore, I'm assuming that it's Ping, and we can also leverage Ping to provide the IWA or using the Kerberos protocol capability as well. In terms of talking about the identity, so in terms of the external identity for the customers, it is mentioned that they would like to give the opportunity to their customers to use login capabilities using Facebook, Twitter, or LinkedIn, and therefore we would need to create the authorization providers for these systems, so that we can allow the OpenID based OAuth authentication and into the mobile publisher based community, so that the users are able to log in social sign-on seamlessly. In terms of the other systems from the customer's landscape, so first, it's a website. So it's a public website from which the inquiries or customers could fill out prospective customers could fill out certain forms, which would be brought into Salesforce as a web delete. So there is a native integration that we are leveraging there. And related to the other systems within the customer's system landscape, So there are two systems. There is a lead capture system, which has been in use till now, where the old leads are captured and the customer inquiries are captured. We would be retiring the system, and therefore we would be leveraging an ETL-like tool, be it Informatica or Talent, which would be connecting to Salesforce using the JWT and using a bulk API 2.0 under the hood to do the large data migration into Salesforce. Also, another tool which is a waste profile. So we will be using which stores the PDF copy versions of the waste profiles for the customer. So this would also be retired. For this, I'll come to the point later how we would do the data migration from this one. The next is MuleSoft. MuleSoft would provide us the capability of pure integration middleware, exposing capabilities of ESB, exposing capabilities of protocol adaption, orchestration, exposing proxy or APIs from the different systems, and pure ESB functions like push messaging and queuing and retrying mechanisms. ESB would be connecting with Salesforce using the JWT and mutual TLS capabilities, and on the other side of sales and on the behind the firewall systems, it will be connecting to the logistics systems and the ERP systems, where it will be connecting to these systems through a VPN capability, through a VPN tunnel, secure VPN tunnel. Next, data model. I'll just very quickly walk through the data model and then keep referring back to it as we walk through the business requirements. So just to level set, so in terms of the legend here, so the ones which are highlighted in yellow are my custom objects here, and the ones which are highlighted in green are my external objects. I'm aware of the fact that there is no one single system from where they pick up information, or the invoice system invoices information is being captured, because there are two separate ERP systems and 4 separate logistics systems. But I would recommend to leverage MuleSoft here, where MuleSoft can provide the capability to query this data using the exposed APIs and expose that back into Salesforce as an OData provider, which can be enabled as external objects in Salesforce. Also, the ones which are highlighted in pink here are the potential large data volume objects, and I apologize, the contact is not highlighted here as a large data volume. Nevertheless, it is, given the fact that we have close to about 500,000 customer contact records here. Now, quickly moving on to the business requirements. So I'll talk about the business requirements. So the sales and the profile setup. Prospective customers will submit the inquiry. So this is straightforward web to lead, and the lead assignment rules, so that it can be assigned to the corresponding support representatives. Alternatively, customers could place a call. So this is where the part with the CTI and the IVR comes to the picture, or customers can also chat, and therefore we would use the live agent capability or the live chat capability and leverage omni-channel here. Approximately 1,000 customers. So here I don't see any issue with the org limits here, because 1,000 prospective customers per month is very much within the limit of the web to lead. The support representatives pre-qualify the customers, prospective customers in Salesforce using short questionnaires. So here I'm assuming that we could leverage a screen flow here to make it more user-friendly way of capturing the simulating a questionnaire. Nevertheless, the fields, the data is stored in custom fields on the lead itself, and upon qualification, the lead can be converted. A waste profile is automatically assigned here, so I'm assuming that this could be a record triggered flow upon creation of an account. An account owner is assigned to the account, and account is created in the backend system, where the ERP system is considered as a system of record from that point onward. So this is where my integration number 1 comes to the picture. Integration number 1 is where upon creation of an account, we are leveraging the remote process invocation fire and forget pattern, utilizing platform events, where the platform event carries the information about the account, the newly created account into the, and MuleSoft subscribes to it using a Comet D client. ERP then sends this information into, does the orchestration and sends this information into the, MuleSoft does the orchestration and sends this information into the corresponding ERP system and in a request and reply pattern, and gets back the external customer ID from the ERP, and then makes a remote call in using a request and reply pattern, makes a remote call in back into Salesforce using the REST API, and updates the customer external ID into Salesforce. And to prevent any other further updates being made in Salesforce on those attributes, we would be leveraging a validation rule. I'm making an assumption that the locations records are manually created by the reps based on the information that was captured through lead convert or through their conversations with the customer during the questionnaire part. At the same time, customer community users, I'm assuming that this is the only creation of the primary customer community users, which can happen through an asynchronous method call where to avoid and not upon the lead conversion, but a separate asynchronous call happens as a future method where the primary customer contact is created and for a community user, and a welcome email is sent out to the customer. Once the customer logs into the, so here this is a point where the customers can create their own waste profiles, and the waste profiles is a custom object here where a customer can associate one or more waste profiles with their location information and also update their location. So location is modeled as another record type within the account object, and it has a relationship back to the same account from which is related to that in terms of the business account. As part of the waste profile, forms of highly interactive and built-in rules must be confirmed. So I believe this can be achieved through a screen flow. The customer submits a waste profile application and reviews the waste specialist. So assuming that the waste profile can have its own stages defined, and the from creation to verification to finalization can happen by following those specific stages onto the waste profiles. The review process of the waste profile requires a system specialist to visit the customer location, and this can, I'm assuming this can be done through tasks. It doesn't necessarily say that those tasks should be automatically created. Nevertheless, even if that is the case, we can relatively easily achieve that by using record-triggered flows, depending upon the profile, waste profile stage. The specialist can take pictures, and this can be, and also geo information needs to be captured, and this can be achieved by creating a custom LWC, which can interact with the using the JavaScript, which can interact with the phone, because the waste specialists who are interacting with the customer at this point of time are leveraging Salesforce standard mobile app. So within that mobile app, there could be a functionality through which they can, using LWC, through which they can capture the geolocation and update that on the location record of the customer. Once reviewed, the sales specialist generates a complete contract. This is where the contract record is created, and contract can also have its own stages, a standard contract object. And once reviewed, the specialist generates a complete contract, including account location. So this is where we can leverage the app like DocuGen. So DocuGen could have a predefined template where which could be initiated. The creation of this document could be initiated from the contract. And could be sent out using the DocuSign for an e-signature. And once the signature once the signature request has been sent out and the customer has confirmed by signing it, the change of the contract e-signing record would trigger an update onto the contract object, marking it signed, and therefore no further, and to ensure that no further changes are possible, we can leverage a validation rule there. Once a waste profile is established, the GRC and the customer can associate the additional locations and existing waste profile in which the waste information, especially. So this is where the customers can have access to their waste profiles because it's associated with their account information, and a sharing rule, a sharing set could be created through which they can access their waste profile information and update or view as accordingly needed. In terms of the pickup scheduling, once a customer is established and they have a waste profile and covered their location, same validation rules, the customer is provided with an interactive scheduling tool so that they can so in terms of the creation of a waste pickup schedule, they can initiate the creation of a pickup schedule through a custom action, which can launch them a screen flow so that it is based on the waste profile and the locations that they have. It can create the pickup schedule. Also, it has a relationship back with the locations account record types, so that one pickup schedule can be associated with one or more locations of that same customer. And once a customer submits the request schedule, a real-time integration can, with the appropriate logistics systems, will automatically add the request and routing scheduling to the logistics system. Here, I'm making an assumption that it's, even if it's a near real-time, then that should still be okay. And therefore, this is where my integration number 2 comes into the picture, where pickup schedule is sent to the logistics systems. A similar pattern, Salesforce fires off platform event towards Mule in a fire and forget pattern. And because it's only a notifier pattern where only header information is sent out from the pickup schedule, nevertheless, other information is also needed in terms of the various different locations which are associated with this particular pickup schedule, the customer information, the contact information. Therefore, for all of that, Mule makes a call back, a remote call into Salesforce using the REST API, fetches all of that information, and Mule writes it, sends it using the API exposed by the logistics systems, and there is an orchestration happening here depending upon into which logistics systems does it need to go. And this is as a result of this successful call, Mule gets back the confirmed schedule ID from the logistics systems, and Mule writes back this information into Salesforce through a remote call and updates the ID received back from the logistics system. The confirmed schedule, okay, yeah. So if a logistics systems need to make a change to the schedule after it is established, for example, by adding a new route, a customer is notified by email, SMS, and/or mobile publish. So this is where I'm leveraging. I'm talking about the integration number 3, where a customer is notified based on the choice that they have. Because this is depending upon the customer's preference, whether it's an email or an SMS or a mobile push notification, which can be achieved through the mobile publisher. Nevertheless, this information has to come to Salesforce. It cannot be done directly from Mule, obviously. Except for the part where we can talk about the SMS. Nevertheless, this information has to come back into Salesforce, where the logistics systems, I'm assuming, can make a push to the Mule system about the changes in the in the schedule. And in a fire and forget fashion, Mule calls Salesforce in a request and reply pattern and updates the pickup schedule, which essentially would be used to fire off the SMS notification, which is in the integration number 5. Because I'm not repeating it in terms of the integration, because this is same integration which is some requirements down the line, which is also talking about sending the SMS notification. Hence, I'm just mentioning it once here, that Salesforce can leverage then the Salesforce can then leverage the Twilio API to send in a fire and forget fashion to send out the SMS to the customer, or an email, or a custom notification which can be sent out to the mobile publisher based app. Pickup and disposal, drivers follow a prescribed route to pick up the waste for the customer. So as mentioned, the routing and the scheduling is done in the logistics systems. Therefore, the route is maintained in the logistics systems itself. Drivers with their device, that the touch device that is available from the logistics systems, can show them the route that they have to travel, and then they can see in the morning which schedule they have, which route they have to follow. While en route, a truck communicates with its logistics systems and sends location. This location information is also saved within the logistics systems itself. Customer should have the ability to query, and so this is where I'm proposing to use a custom LWC. So the custom LWC, the way I imagine this thing is that, so I forgot to mention something here, that in terms of the details about the logistics systems, it says that there are 4 logistics systems and all. This is the most important thing. The logistics system provides a touchscreen device in the truck and to guide the driver for each stop, and tracks each pickup as it occurs. Therefore, I'm making an assumption that the pickups are somewhat is a record which is maintained within the logistics systems itself, which can be exposed back into Salesforce as an open data or data provided information. Hence, the pickup record, which is available in terms of a schedule for today, as related to the routes, each one of those pickups could be exposed back into the Salesforce. So imagine I'm a customer, I'm looking at a pickup record that is available through a Lightning component within the community. And if I press on a button within that Lightning component to show me the expected time, or show me the location of the truck which is coming to pick this up, this is where the integration number 4 would come to the picture. So SF is going to call a mule endpoint, which is going to call logistics endpoint in a request and reply pattern, and the API exposed by the logistics systems is going to provide the current location of any given truck which is on that particular route for that particular pickup. And this is going to be exposed back into the Lightning component as the current location of that truck. The logistics systems has the okay, yeah. So if there are any issues during the pickup, the drivers would be able to. So this can be for this also the drivers could also leverage the Salesforce standard mobile app and create a case and provide comments or charter posts onto the location or the customer case records. The logistics systems has the ability to notify the external system upon the completion of a pickup and upon completion of the route. So yeah, it's like in the beginning, as and when the trucks keep doing the pickup, they mark the pickup complete. This information is saved back into the logistics systems, and logistics systems provides this communication back to the customer. There's one part which is mentioned in the beginning, which is about the nightly batch job between the logistics systems and the ERP systems, which is a batch data synchronization integration pattern using the APIs between the two systems. So from the logistics systems to the ERP systems, it's whenever a pickup is complete, and from the ERP system to the logistics is only new customers from which the ERP system would have received during that day are also synced within the logistics systems as well. In terms of the data migrations, customer leads. So in terms of the leads information, which is captured here within the lead database. So we would need to, moving on to the data migration requirements of the lead database, which is going to be retired. We would need to extract it, bring it into an ETL systems raw schema, where this would be deduplicated, standardized, and this is where we would also have to load the existing ERP system, existing customers from the ERP system also, so that we can hash out if a customer has already been converted. I'm assuming that for this one, we would have to use some sort of like a probabilistic matching capability, like if the name or the email matches with an existing record which is already in the ERP. So for those, we can reject those, remove and reject those leads as they are no longer a lead, they have already been converted. And whatever is the final remaining cleaned record, those leads would have to be loaded into the system further. All customer accounts and locations. So of course, this is also from the ERP and the logistics system that we would need to extract, deduplicate, and come up with establish a global party ID. I understand that there is a in the scenario it says that the same customer could exist in one or more ERP systems. So therefore, we would need to maintain the party ID of both the ERP systems onto the Salesforce in a way so that it provides the handshake capability from Salesforce into that ERP system. Nevertheless, MuleSoft would be able to do the orchestration depending upon to which ERP system it has to communicate, and similarly goes for the logistics systems. So for the logistics systems, we are getting the global party ID only for the location records, and therefore on the location records, whether it's a medical waste or whether it's an industrial waste, we can establish those IDs of the logistics systems onto the location IDs itself. When it comes to the requirement about the bringing into Salesforce the waste profile, existing waste profile PDF docs. I'm assuming that these can be scanned. There are no issues in terms of the scanning or the quality, and therefore it can using a tool like Doc Parser or something where it provides the capability of converting it into a digital copy of a scan records, and therefore that particular record, the scans could be loaded into Salesforce as files, plus the values, the parser that provides based on that we can create the existing waste profile records in the system and associate them with the accounts. I'm assuming that at least on the scans or somewhere on the file we can find out what is the account external ID, which is corresponding to the ERP system, and based on that we can upload the waste profiles into Salesforce as well as use the same naming convention for the files. Moving on very quickly onto the reporting, some of the reporting capabilities which are there, where the management needs to run some ad hoc trending historical reports. So I'm assuming that this can be done using Tableau CRM itself. All customer contacts should be able to run reports and show to view their issues and their statuses. So I'm assuming that it doesn't literally translate to reports as in reports, but some of those can be achieved by using case list views. And for the historical ones where we would have migrated, we would have offloaded the data to Heroku, we can use a custom Lightning component which can fetch the data from the Heroku archived tables related to the case, and then show that in a list table kind of component. Customer contact should be able to run historical reports both in summary and detail to pick up the waste. Again, so for this one also, I would imagine that we can leverage the two external objects here and use a custom Lightning component so that this data can be exposed in a secure way, and the customer doesn't have access to the more information because the external objects don't provide row level security, and we can control that in the server-side controller of our Lightning components. GRC would like to report that can be run live on the public website. So for this one, I'm assuming that a public website could create a component which can be using, let's say, chart.js or any other reporting capabilities, and in the and query Mule endpoint, which would essentially be querying the live data. The reasoning here is that we don't want to expose our live data from Salesforce directly to the public website, and therefore Mule can provide the endpoint protection or rate limitation and a couple of other capabilities and make it accessible to the external systems in a secure way. Last but not the least, in terms of the data volumes, I imagine like I mentioned briefly in terms of my data model, that there are certain LDVs. In terms of the accounts, which are the business accounts, we would have to make sure we are having selective queries. There's whichever automations we are writing, we would need to make sure that the queries are selective, and we are leveraging indexed fields, and we are limiting using various different filters within our queries. During the development, I would imagine that this is done always where we are, before we push any functionality to production, we are always performance testing that in a full copy sandbox, and before that functionality gets pushed off to production, and in production where it hits the real data, where we run into the non-selective query issues. But as a long-term solution, I would imagine that, like I briefly mentioned, we would leverage Heroku to archive. We could start by doing any kind of like a data retention policy where once the record has been inactive for X number of months, we can archive it. Similar goes for the locations. For pickups and invoices, it's a very large data volume, and therefore we have to keep it completely out of platform as an external object. In terms of the case, it doesn't say pretty much, it doesn't give any indication of what should be the volume here, but nevertheless, I would imagine that we would need to implement similar best practices in terms of querying using custom indexes and very specific criteria based on the statuses or the dates. And as a long-term solution, archive it based on the data retention policy, let's say X number of days after the case has been closed. And that concludes my presentation. Thank you.